Example 3 says write the general term for the geometric sequence 3, 6, 12, 24, 48, etc. Then use the formula to find the 8th term. So it's 2 steps here. The first thing is we're going to write that general term, which means write the formula to find the nth term. So that's where we're going to use that a sub n equals our first term times the common ratio raised to the n minus 1. They're wanting us to fill this in, but remember, if you're just writing a formula, you're going to leave n as n, okay? Because you don't know what term you're going to be looking for sure at this point. Now, I know the next sentence says, then use to find. That's when we'll change and we'll actually have an n value. So just for this first part, to write the general term, we don't know n, because it's just a general term formula. So what's a sub 1? And what is my common ratio? How are we going to find it? Second term divided by the first term. Could have done the 4th term divided by the third term. 5th term divided by the 4th term. It doesn't matter. They all give us 2, right? Which it should. It's common ratio, which means it's in common between every term. If not, this isn't a geometric sequence. All right, so for my formula, I get a sub n equals, what was my first term? 3 times r, which is 2 raised to the n minus 1. Can I do anything else there? Can I multiply the 3 and the 2? No, because PEMDAS tells us we do exponents first, and we can't do anything with that n minus 1 up there, can we? So, unless we can get rid of that exponent, we're stuck right there. So, we're not going to do anything else. So, there's my formula. Then it says, then use the formula to find the 8th term. Well, if I'm after the 8th term, what do I know? I know n. What is n? 8. So I'm looking for a sub 8. You just told me my formula is 3 times 2 raised to the n, which you just said is 8, minus 1. And what do we do first? Exponents. So it's 8 minus 1. And what do we do next? The exponent part. So I got 3 times, what is 2 to the 7th? And then multiply by 3. Say it again. 384. And so there's our 8th term in that geometric sequence.